In 1985, an engineer at Digital Equipment Corporation was given an impossible problem on a Friday afternoon. By Monday morning, she had solved it, and her solution now runs every Wi-Fi router on Earth. Her name is Radia Perlman. The algorithm is called the Spanning Tree Protocol. And by the end of this video, you will know how a single engineer, working alone over a single weekend, designed the invisible plumbing that quietly holds the modern internet together, and why almost nobody knows her name. 1984. Ethernet has just won the local area network wars. Companies across the world are wiring up their offices and connecting their computers with Ethernet cable. It works beautifully until you try to connect two networks together. The moment you bridge two Ethernet networks, you create a loop. Data packets that were supposed to travel from one computer to another start circling between bridges forever, multiplying, choking every wire. Network engineers call this a broadcast storm. Within seconds, the entire network collapses. In 1985, this is an unsolved problem. Companies running larger and larger networks are watching them die over and over. Digital Equipment Corporation, at the time, the second largest computer company in the world, has a customer crisis. Their networks keep failing. Their bridging hardware does not have a solution. DEC's manager walks into the office of one of their network engineers on a Friday afternoon, drops the problem on her desk, and says he needs an answer by Monday. The engineer is Radia Perlman. She is in her early 30s. She has a PhD from MIT. She has been writing networking code for years, and she goes home for the weekend with one of the hardest open problems in distributed computing on her to-do list. By Monday morning, she has the answer. She has designed a new algorithm. She has proven mathematically that it works, and she has written a poem describing it. The algorithm is called the Spanning Tree Protocol. Its job, in plain English, is this. When you have a mesh of network bridges with loops in it, the bridges automatically negotiate among themselves to identify exactly one path between any 2 points. Then they politely shut down every other path until one of them fails, at which point the bridges renegotiate and bring an alternate path back online. Loops eliminated, broadcast storms impossible, redundancy preserved, self-healing, decentralized. The protocol Perlman wrote over that weekend in 1985 was published as a research paper in the same year. It was adopted as an industry standard by IEEE in 1990, designated 802.1d, and then it kept being adopted, and kept, and kept. Today, the Spanning Tree Protocol, or one of its direct descendants, like Rapid Spanning Tree and Multiple Spanning Tree, runs in every managed Ethernet switch ever built. It runs in every Wi-Fi mesh system. It runs in the network backbone of every data center. It runs in every corporate office network on Earth. It runs in your home router. When the Wi-Fi at your house keeps working even though one of your mesh nodes died, that is spanning tree. When a data center reroutes around a failed switch without dropping your video call, that is spanning tree. When the airport Wi-Fi survives a maintenance crew unplugging a cable in the back room, that is spanning tree. The protocol Radia Perlman invented in a single weekend in 1985 has been quietly running, without serious modification, for 41 years. It is, by some measures, the single most used algorithm in computer networking, and it works essentially the way she first wrote it down. About the poem. Perlman published her algorithm with a verse called Algorhyme, written as a tribute to Joyce Kilmer's 1913 poem Trees. It begins, "I think that I shall never see a graph more lovely than a tree." Engineers love this story for two reasons. First, it captures something true about Perlman's approach. She treats networking as an aesthetic problem, not just a technical one. Second, it is, as far as anyone can tell, the only foundational internet protocol ever published with an attached poem. Spanning Tree was not Perlman's only contribution. Across her career, she also invented the IS-IS routing protocol, which runs the internet backbones of major service providers worldwide. She wrote the standard textbook on network protocols, titled simply Interconnections, published in 1992 and still used in graduate networking courses today. She also led the work on TRILL, a protocol designed in 2010 to replace spanning tree, a project where she essentially proposed retiring her own most famous invention because she believed she could do better. The networking community calls her the mother of the internet. She hates that title. She has said in interviews that nobody invented the internet single-handedly, and the term overstates her role. She prefers to be called an engineer. Here is what is strange. For someone whose work runs essentially every Ethernet and Wi-Fi network on Earth, Radia Perlman is almost completely unknown outside computer science. There are no biographical films. There is no Time magazine cover. Most people who use her algorithm every day on every device in their home have never heard her name. The spanning tree protocol just works. And the kinds of inventions that just work for decades without breaking, without needing maintenance, without becoming news, never make their inventors famous. The recognition curve in technology bends toward visible failure, not invisible success. Perlman is the most successful network engineer of her generation. By far, almost nobody knows. And here is the deeper part of this story. The kind of invention Perlman made, a quiet algorithmic backbone, designed once, deployed everywhere, never modified, is the kind of invention modern technology depends on completely, but no longer rewards. Today's tech-famous names are entrepreneurs, founders, personalities, people who built products, the people who built protocols. The invisible standards that let billions of products talk to each other are almost all anonymous. You probably do not know who invented TCP/IP. You probably do not know who invented Ethernet. You probably do not know who invented the domain name system. You probably do not know who invented the algorithm that lets your Wi-Fi router survive a power blink. But you use all of them, right now, to watch this video. The world we live in is built on a substrate of these quiet inventions. Spanning tree protocol is one of the most important. It is, in a real sense, the reason networks above a certain size are possible at all. Without it, or something extremely similar, the modern internet, the corporate office, the data center, the Wi-Fi router, the smart home, none of it works. And it was invented over one weekend in 1985 by one engineer at a now-defunct computer company who attached a poem to it and then quietly went back to work on the next problem. Radia Perlman is, as of 2026, still working as an engineer. She has held senior positions at Sun Microsystems, Intel, and Dell. She has published over 100 papers. She holds more than 100 patents. She is, by most external metrics, one of the most accomplished computer scientists alive. Outside the field, almost nobody recognizes her name. The next time your home Wi-Fi reroutes around a dead mesh node without you noticing, the next time your office network keeps working even though a switch died, the next time you walk through an airport that has been quietly load balancing thousands of devices for hours, there is a 41-year-old algorithm written over one weekend by Radia Perlman, holding the whole thing together. Progress is sometimes a famous founder. More often, it is an engineer nobody remembers, solving a problem nobody saw in a building that no longer exists, on a deadline that has been forgotten, whose work is now load-bearing for the lives of billions of people. That wraps the first month of Obsolete Origins. If you have made it this far, you are exactly the kind of viewer this channel was built for. Next Sunday, Bluetooth, named after a Viking king who has been dead for over 1,000 years. Subscribe so it shows up. I will see you Sunday.